Hi, and welcome to TEMEKO. In this video, we are going to dive deeper into the topic of energy and get more familiar with one of the most famous concepts in mechanics, which is conservation of energy. During the video, we are also going to learn how to solve different types of problems related to this concept. Let's get started then. As we have discussed earlier, conservative forces such as weight and spring force can do work when they are trying to return the particle back to its reference plane or datum line. We can determine this work, which is done by conservative forces, as a change of potential energy. How is this possible, you may ask? Well, it's possible because of their relation, which is that energy is the capacity of a force to do some kind of work. Therefore, we can express this work mathematically as summation of U 1 to 2 conservative equals V1 minus V2. Now, by considering this work equation further, we could write an equation for the principle of work and energy as follows. V1 plus T1 plus summation of U 1 to 2 non-conservative equals V2 plus T2, which we can also present differently as shown here, where summation of U 1 to 2 non-conservative is the work done by non-conservative forces such as frictional forces. As you may have already figured out, this equation describes what we have already discussed about energy conservation earlier. The total initial energy of the system equals to the final total energy minus the possible energy which is transferred to another form by non-conservative forces. In cases where there are no non-conservative forces present, this equation gets simplified as follows. V1 plus T1 equals V2 plus T2. We call this form of equation as conservation of mechanical energy. This equation is quite useful, for instance, if we want to solve the final velocity of a ball when it hits the ground from a certain height. On the other hand, we could also solve an opposite type of problem, in which we solve how far in the sky the ball can reach if it has some initial velocity by using the same equation. Now that we are familiar with the concept of conservation of mechanical energy, let's see the steps that we can use to solve every single problem that is related to this concept. In such problems, most often we are asked to solve the particle's potential energy first. In order to determine this potential energy, the first thing that we could do is to draw two diagrams which are showing its initial and end positions. This presents the displacement of the particle for us. If the particle has some vertical displacement, we should also establish a fixed datum line. Finally, we can determine the potential energy of the particle by using our familiar equations. After we have solved potential energy, we can start to apply the equation of conservation of mechanical energy, which has been presented previously in this video. In case we need to know how much kinetic energy the particle has, we can determine it by using a kinetic energy equation that is already familiar to us. And that's it. Now you have the measures to solve every problem related to conservation of mechanical energy. Hopefully, after watching this video, you are more familiar with the concept of conservation of mechanical energy. You also know the steps which you can use to solve the related problems. Thanks for watching and have a nice day.